So now we're going to move on to the oh so fun part B. Next question is find the acceleration of A with respect to B. So why don't we just move on? Right. Um, if it says 100 here, actually I'm not going to write that as 100. I have a chance to change this. This is just going to be R meters, since it might not be 100 for you guys. So we want acceleration of A relative to B, which we just said from up here, this thing. If we take the derivative of this in terms of time, we're going to get the same order of the letters, just it's going to be A instead of B. There we go. So, acceleration of B we're given. So that's just going to be in the I direction. We need to find acceleration of A. Now, here you might plug in 0 and say acceleration of A relative to B is just negative acceleration of B. That's wrong, because A has no tangential acceleration, but because it's turning, it must have centripetal acceleration. You can't miss that. So we have R here, with this going at some V, and this at some angle beta, right? We want to find our centripetal acceleration, which is going to be in this direction. As it has to be turning constantly. So we're just going to come up with a quick little, I guess it's not really so quick, but no, it's pretty quick. Radius here is given to you in meters. If it isn't, if it's given to you in kilometers, then keep it as it is, but it should be given to you in meters. So whatever this radius is, multiply it by, what do you multiply it by? Oh, 10 to the negative 3. To get your radius in kilometers. That's what the radius km means. Convert the radius in meters times 10 to the negative 3 to radius in kilometers. Next, we want to find acceleration of A, which is V squared over R, which is just VA squared over RKM. There we go. So now we got our acceleration. Now we got to figure out, oh, this is going to be fun, in Cartesian vector form. So let's see what angles we got going on. So if we just, since you can superposition and move these around as much as you want, acceleration here, the horizontal is given by beta. This angle here is also beta. This is acceleration. So and now notice that acceleration is going in the positive I direction and the positive J direction. So there are going to be no negatives in this except when we subtract, because that just makes sense. So I'm just going to write down what our acceleration of B is. It's just, B is a nice easy one. It's very hard to mess up with B. I plus 0 J. Well, what we're more concerned with is acceleration of A, which isn't still very complicated. It's not that complicated still, but whatever. So here, if you want to find in the I direction, it's just going to be acceleration of A times cos of beta. In the I direction. plus acceleration of A times sine of beta in the j direction. Now this is just straight by triangle and finding components of this. Cos of b, beta gets you x, sine of beta gets you y. So that's where these come from. Now we know that acceleration of a with respect to b is the difference between these two. So we're going to go acceleration of a with respect to b equals acceleration of a cos b I plus acceleration of a sine beta j minus acceleration of b in the I plus 0 in the j. We got acceleration of a in terms of b. This is just going to be acceleration of a cos beta minus acceleration of b in the I direction plus acceleration of a sine beta in the j direction. Now remember, acceleration of a here is from here is va squared over r km. I'm just going to plug that in the very ending, which is coming right about now. You got now again it asks you for the absolute value of a in terms of a acceleration of a with respect to b, which is just going to be root. I'm going to give myself a lot of space this time. A cos beta minus a b squared plus a sine beta squared. There. Now I'm just going to plug in what a acceleration of a is. So we have va squared over r km cos beta minus acceleration of beta, or acceleration of b squared plus va squared over r km sine beta squared. And that is our expression of the absolute value of acceleration of a with respect to b. Fun stuff, right?